Bismillahirrahmanirrahim. Sallallahu alayhi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa sallam. Ameen. Alhamdulillahi rabbil alamin. A2P3 Differentiation. Lecture number 1. We should be kind to others. Functions. There are 5 types of functions in our syllabus: algebraic, exponential, logarithmic, trigonometric, and inverse trigonometric. So these are 5 functions of in our syllabus. Differential operator. D upon dx. This is known as the differential operator, and we use this operator to differentiate the polynomials. How does this operator work? It makes the power coefficient and subtract it by 1. So this is the way this operator works. The word differentiate means multiply d upon dx with the given polynomial. Now let's solve a few examples of this to understand how does this operator work. Differentiate the following with respect to x. X power 8, 5x cube, under root x, 5 under root 5x. So in order to differentiate x power 8, we need to multiply d upon dx with x power 8. So this is the step number 1. Always multiply d upon dx with the given polynomial. This is the answer. 8 will become coefficient and the power will become 7. 5x cube. So this is very important. Multiply 5x cube with d upon dx and then the answer will become 15x square. Under root x, you all know, you already have done under root thing in A1. This under root x will become 1 upon 2 root x and the differential of x is 1. This is the way we differentiate under root x. So the final answer is 1 upon 2 root x. D upon dx under root 5x, well, this will become 1 upon 2 under root 5x and the differential of 5x is 5. So the answer is 5 upon 2 under root 5x. Differentiation of algebraic functions. Let's begin with simple algebraic functions. So this is the formula of simple algebraic function. This power will become coefficient and n minus 1 should be the resultant power. D upon dx, x. The differential of x is 1. The differential of constant is always 0 and 3 is coefficient. Therefore, the differential of 3x is 3 times 1, which will become 3. D upon dx under root x. We already have done this. This will become 1 upon 2 root x and the differential of x is 1. This is the way we differentiate under root x. 1 upon x. To differentiate 1 upon x, we need to bring x in numerator and then we can differentiate it. So this is the direct way of differentiating 1 upon x. It will become minus 1 upon x square. 5x plus 3. Well, 5 times 1 plus 0. So the final answer is 5. 2 upon 3x. You need to bring x in numerator. Before differentiating, always simplify the function. So in this case, we need to bring x in numerator and then we can differentiate this. So the final answer is minus 2 upon 3x square. Here we need to first simplify this fraction and then we can differentiate this fraction. Well, while simplifying the function, we always copy d upon dx. So always copy d upon dx during this simplification. So it will become 5 upon 3 and 2 upon 3x minus 1. This is the simplified form of the fraction. Now we can differentiate this function. So as soon as we differentiate, we remove d upon dx. See, we differentiated 5 upon 3, we remove d upon dx. So this is very important. Always copy d upon dx during the simplification and remove d upon dx as soon as you differentiate the function. So 5 upon 3 will become 0, 2 upon 3 is the coefficient, so it will remain 2 upon 3, and x power minus 1 will become minus 1 x power minus 2, and this is the answer, the simplified form. Composite algebraic functions rule. This is the composite algebraic function, and the rule is first make power coefficient, then subtract power by 1, and then differentiate the bracket. During the simplification of the power, while handling the power, copy this function. So always copy the function while handling the powers. And then after settling the powers, you can differentiate the bracket. So this is the way to differentiate ax plus b whole power in composite function. Now under root. Well, to differentiate composite function in square root, you can write 1 upon 2 square root and then differentiate the function inside the root. So that's the answer of this function. Another example, or an example of composite function. How to differentiate this function? See, first make power coefficient, subtract power by 1, copy the function during the simplification of the power, and then differentiate the bracket or function. And this is the simplified form of the function, the answer. Sorry. So under root. For under root, write 1 upon 2 square root and then differentiate the function. The differential of this function is 3. And this is the simplified form of the answer. 10 upon 3, 1 minus x. Here you need to bring 1 minus x in numerator. So this function has power minus 1. Let me correct this power here. This is minus 1. So how to differentiate this? This is very simple. 10 upon 3 is the coefficient. So copy the coefficient here. Make this power coefficient. Subtract the power by 1 and then differentiate the function, and the differential is minus 1. So this is the answer. Well, you know, y is equal to x power n. So in order to, this is the equation. This is very important. First time we are discussing the equation. Before that we were discussing the polynomials. So y is equal to x power n. In order to differentiate this equation, we multiply d upon dx on both sides of the equation. Now this will become dy upon dx, and the right side will become n times x to the power n minus 1. Well, you can do this directly. So if we have y is equal to x power 5, so the differential of y will become dy upon dx, and the differential of x power 5 will become 5x to the power 4. Example number 2, dy upon dx on left side, 2 upon 3 is the coefficient, and the differential of x power 8 will become 8x power 7, and the simplified form is 16 upon 3 x power 7. So these are some important notations. If y is equal to f of x, then dy upon dx will be f prime x. The differential of y is dy upon dx, and the differential of f of x is f prime x. The second derivative, the differential of dy upon dx or second derivative is d2y over dx2. And in f form, it is f double prime x, where dy upon dx can be written as y prime, and d2y over dx2 can also be written as y double prime. Polynomials and equations. Polynomial, the word polynomial means many terms. This is the polynomial and this is the equation. An equation is a combination of two different polynomials, and which is true for particular value or values of x. Equation is always true for particular value or values of x. Well, To differentiate polynomial, we always multiply the polynomial with d upon dx and then we can differentiate the polynomial. So make sure you always multiply polynomial with d upon dx. This is the step number 1. If you won't write d upon dx, you will lose 1 mark. Well, to differentiate equation, you can directly do this by writing dy upon dx on left side and the differential of the right side. It's 5x4. You don't need to mention d upon dx in equation. You can differentiate the equation directly. But in polynomial, you always need to mention d upon dx at the first step. This is very important. Well, in fx form, so if f of x is x power 5, therefore the differential of f of x will be f prime x and it will be 5x4. And this is the second differential, f double prime. So it will be 20x power cube. Where dy upon dx is f prime x is called the gradient of the tangent to the curve at the point, at any point, pxy. So dy upon dx or f prime x is basically gradient of tangent to the curve at any point pxy. So if this is the curve, so gradient, this is the tangent line. Therefore, the gradient of tangent is always represented by dy upon dx, and the gradient of normal is the inverse reciprocal of the gradient of tangent, because tangent normal is always perpendicular to the tangent. So if dy upon dx, let's suppose if dy upon dx is 3 upon 2, then the gradient of normal will be inverse reciprocal of 3 upon 2, which is minus 2 upon 3, because normal is always perpendicular to the tangent. I wrote 2 upon 3 here, so let me correct this. So this is 2 upon 3. Let's suppose 2 upon 3. 3 upon 2 was also fine, but on the next page I wrote 2 upon 3. So that is why I am changing this thing. So this will be minus 3 upon 2, because normal is perpendicular to the tangent. Product rule. It is used to differentiate the product functions. So make sure you always use product rule to differentiate the product function, and the rule is uv prime plus vu prime. When two functions multiply, we use this rule. According to this rule, we copy first function and we differentiate the second function. V prime means the differential of v. Then we put plus sign and then we copy the second function, that is v, and we differentiate the first function, which is u prime. So this is the example of the product rule. These are two functions. We cannot simplify these two functions, so we have to use product rule here. So according to product rule, we need to copy u, this is u, and we need to differentiate v, and this is v prime. You know how to differentiate the composite function. We already have discussed this thing. So 5 bracket copy power 4, and the differential of the bracket is 3. Then you need to copy according to the rule v, and then you need to differentiate the first function u, which is u prime, 2x. I wrote this here, u v prime, v u prime. So in this rule, we usually take common. So this bracket is common. The composite function is always common in this rule. So the simplified form of the differential is x times 1 plus 3x whole power 4, 21x plus 2. Quotient rule. Well, we use quotient rule when two functions are divided. It is used when two functions are divided. So u upon v. The rule is we square the denominator like v square, and then we copy v, and then we differentiate u, then we copy u, and then we differentiate v. So that's the rule. You need to remember these two rules, product and quotient rules. This is an example of the quotient rule. So we cannot simplify these two functions, therefore According to quotient rule, we need to square the denominator, and then we need to copy denominator here, and we need to differentiate the numerator. So the differential of numerator is 5. Then we need to put plus minus sign, copy u, and differentiate v. Well, this is the simplified form of the differential. Equations of tangent and normal. Well, this is the equation of tangent and this is the equation of normal. The difference is gradient. Here we write dy upon dx in the equation of tangent, and in the equation of normal we write mn, the inverse reciprocal of the tangent's gradient. Now this is the question: find the equations of the tangent and normal to the curve y is equal to x square plus 8x at 1, 2. So the concept is we need the gradient of the tangent and the gradient of the normal in order to get the equation. We have the point. So for gradient, we need to differentiate the equation of curve. This is the gradient of the equation tangent to the curve, the expression of the gradient, in fact. Now at x is equal to 1, the gradient of tangent is 10, and the gradient of normal will be inverse reciprocal of 10, which will be minus 1 upon 10. So this is the equation of tangent. Make sure you write the right gradient here, because you are working for tangent, so you need to write dy upon dx here. And for normal, just change the gradient. The inverse reciprocal of the gradient of tangent should be here, and this is the equation of the tangent. I have to discuss a few more things, so let me change the sheet, the file. Stationary minimum and maximum points. Minimum points. Stationary means minimum and maximum points and values. Stationary points and stationary values. This is the topic. So for stationary points and for stationary values, values means vertical coordinates. Use dy upon dx to 0. If you need a stationary point or if you need stationary value, you need to equate the gradient first derivative or gradient of tangent to 0. In this way, you can easily get the stationary point and stationary value. Well, if SHK, if this is the stationary point, then this K is the stationary value and its corresponding value of x is h. Make sure you must know this thing. If this is the point, then this vertical coordinate is the stationary value, and its horizontal coordinate of the stationary point is the corresponding value of k, which is h. Well, there are two possibilities. Gradient is 0. Why gradient is 0 at a stationary point? Because at a stationary point, tangent is horizontal. That's the logic. We equate gradient to 0 because at stationary point, tangent is always horizontal. Example. Find the stationary value of this function. So in order to get the stationary value, we need to differentiate the function first. So the differential of y is dy upon dx and the differential of the right side is 2x minus 8. So for a stationary point or a stationary value, we need to equate gradient to 0. Hence we have got x4, which is the x coordinate of the stationary point and which is written as h. By substituting this 4 into equation of curve, we can get the y coordinate of the stationary point. This is the value of k, the vertical coordinate of the stationary point, and this is known as the stationary value. Hence, the stationary value of y is negative 16 and its corresponding x is 4. Next topic, the nature of stationary points and values. For the nature of stationary points and stationary value or values for both, we find second derivative and then we observe its sign at x is equal to h. So for both nature of stationary point and stationary value, we always work for second derivative and then we observe its sign at x is equal to h. So we have two possibilities. There are two possibilities. If the second derivative is positive at x is equal to h, then we say the point is minimum, and this k is the minimum value of y. If the second derivative is negative at x is equal to h, then s is the maximum point, and then this k is the maximum value of y, where s is the stationary point. Example. So we need first derivative and second derivative of this function. Y is equal to x minus, number one, we need to simplify this function. We need to bring this x minus 3 in numerator. So this is the simplified form of the function y, and this is the first differential. The differential of x minus 3 will be minus 1 times x minus 3 power minus 2, and the differential of bracket is 1, and the differential of x is 1. So this is the simplified form of the first derivative. In order to find second derivative, we need to differentiate this form of the first derivative, this one. Don't differentiate this form, differentiate this one. Well, this is the second derivative, and this is the simplified form of the second derivative. Now find the coordinates of maximum point and minimum point. For stationary points, you all know we equate gradient to 0. Therefore, this is the first derivative, and we equated this to 0, and we got, because of this power 2, we got plus minus here because we took square root on both the sides. Therefore, we have x4 and x2, and their corresponding values of y are 5 and 1. At x4, the second derivative is positive. At x4, the second derivative is positive. Therefore, 4, 5 is a minimum point. This is the way to check the nature. If the second derivative is positive, then the point is minimum, and the value is also minimum. At x2, the second derivative is negative. Therefore, this point A is a maximum point. Increasing and decreasing functions. For increasing function, gradient is always positive. For decreasing function, gradient is always negative. Well, for quadratic functions, for quadratic increasing function, gradient must be positive at x greater than h. For quadratic decreasing function, gradient must be negative at x greater than h. Let me correct this. This is x greater than h because we make tangent at x greater than h. For quadratic increasing, gradient should be positive at x greater than h. For quadratic decreasing, gradient must be negative at x greater than h. Well, this is the quadratic function, and show that this function is a decreasing function. Well, we need to get gradient of this function first, and its h is half. So we need to substitute any value which is greater than half. So let's suppose x is 1 because this value is greater than h. You can suppose any value. You can suppose 2, 3, 4, 5. Anything which is greater than half should be substituted in the gradient. So the gradient is negative. At x1, gradient is negative. Therefore, the function, this is x greater than h. Let me correct this. Greater than h. Therefore, y is a decreasing function. When gradient is negative at x greater than h, then function is decreasing. This is for nonlinear functions. Let me discuss this as well. Nonlinear functions. For nonlinear increasing and decreasing functions, we observe the function of gradient, that is dy upon dx. The gradient of the function, in fact. Function's gradient, let me correct this. Function's gradient, that is dy upon dx for the given domain. If the gradient of the function is positive for the given domain, then the given function is an increasing function, and vice versa. Basically, functions other than quadratic, we find gradient and then we observe the gradient according to the given domain. So let's suppose this is the function f1 upon x cube minus x cube. This is not quadratic. For x greater than 0, show that f of x is an increasing function. This is very simple. We just need to find gradient first. So this is the expression of the gradient. Now you need to substitute any value. Mentally, you can just substitute any value of x which is greater than 0. Let's suppose if you substitute 1, you will get this answer positive, and this is negative, so answer is negative. So this thing, when x is greater than 0, see, when x is greater than 0, then this bracket is always positive. And because of this negative sign, this bracket will become negative. This is very important. Hence, f prime x is less than 0. Therefore, f of x is a decreasing function. When gradient is negative, then the function is decreasing. That's all. This was the lecture number 1, and I will discuss the important things of differentiation, like differentiation of trigonometric, exponential, logarithmic, and inverse trigonometric, and other things, implicit and parametric equations, in my next lectures. We should be sincere with everyone. Allah Hafiz, inshallah. I will discuss the remaining things in my coming lectures soon. Allah Hafiz.